Hello, and welcome to another online learning day for science. Our essential question that we will be focusing on today was technically two of them. What are the particles in an atom, and what is the location and charge of each of those particles? So remember, this unit is about the solar system, but we're starting this unit thinking, well, if I really want to understand the things in the big picture, the solar system, I need to know some of the little details. And so that's why we're focusing on particles and atoms first, and then we'll get into the things you're more familiar with, things like, oh, planets and moons and satellites and stars and things like that. But we want to know the details before we get to the big picture. And so that's why we continue to talk about particles and atoms, like the tiny pieces that are out in space. So go ahead and set up your notes for today. Subatomic particles is the name of our topic. And then the essential question, I kind of combined the two from before in just thinking about what particles make up everything. If you're taking these notes on the assigned day, it is 10/28. Otherwise, fill in whatever date it is that you're taking these notes. And let's learn some more about subatomic particles. Sub meaning lower than, so lower than the atom. So what are the particles inside an atom? That is our focus. And then just remember for our notes, you don't have to write down anything that's in white. Those are just things that I want to say or directions or reminders. And then it's the things that are in any color other than white. Those are the things that you write down for notes, starting with these green things on your note page. So we know that everything is made of particles. This was part of our discussion on the kinetic molecular theory from the other day. So everything is made of particles, and those particles are always moving. What are the particles made of? So if everything is made of something, right, we need to keep going a little bit smaller. So if we say that everything is made of particles, well, what are those particles made of? And let's actually call them atoms. So really we want to know what are atoms made of. So particles are made of subatomic particles. Now think about it. If we were in person right now, I would have you call out, what are the things you already know about the atom? Well, but for now, since you're by yourself, you can just say things out loud to yourself or jot down some ideas. What do you already know about the atom from other science classes or your own reading, or your family talks about stuff? What do you already know about atoms and subatomic particles, the things inside atoms? What do you already know? So maybe you're thinking of words like protons or neutrons or electrons or energy levels or nucleus. I don't know. Those are just maybe the things you've heard of. But even if you've never heard of any of those, that's what we're going to talk about next. So go ahead and set this up in your notes. So atoms is what we're talking about. And set up a chart that is 1, 2, 3, 4 across and 1, 2, 3, 4 down, and then make dividing lines. Pause the video if you need to. Set up a chart that looks like this about atoms. All right. And then in it, we're going to talk about what's the name of the subatomic particle, what is the location of that particle, what is its size compared to the other particles, because all the size of all of these things are teeny, 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 tiny. We can't even imagine. But compared to each other, what are their size? And then what is the charge? All right. So the first subatomic particle. So again, pause the video if you need to finish setting up your chart. The first particle we're going to talk about are the protons. They are located inside the nucleus of an atom. The nucleus is like the center part. The size of a proton compared to the others is considered big, and its charge is positive. So inside the middle of the atom, you have these positive protons in the nucleus. The neutron is another name of a subatomic particle. It is also located inside the nucleus. So in the center, these two particles are smashed together inside the nucleus in the middle of the atom. They are also considered big. So these are about the same size, but the charge on a neutron is neutral. There's no charge on it. So when you put these two particles together, the total nucleus has a positive charge because you've got nothing charge and positive charge. So together, the nucleus is positive in the center of the atom. But the problem is that if this was the only part of the atom, everything around us would have positive charges and would try to push away from each other. So there's got to be something that balances that positive nucleus, and that is your electron. That's the name of the subatomic particle. The location is that it's flying around the nucleus in different levels. There's small levels close to the nucleus, and then levels get bigger and bigger as you go away from the nucleus. And depending on how much energy electrons have and how much they're flying around, that will kind of determine which level they're in. Now, here's the kicker. The electrons are really small compared to the others. So if a proton and a neutron are considered big, an electron is considered like really small. One comparison that people make sometimes is that if you took your nucleus and you compared it to the size of a marble and you put that marble on the 50-yard line of a football field, the whole rest of the atom would be where the electrons are flying around. But because they're so small, a lot of the atom is just kind of empty space. So the nucleus and those particles are considered big, but they're smashed in the center in that nucleus. And the whole rest of the atom is a whole bunch of space where the electrons fly around. Okay, but then remember how we said that most things in the world are neutral? They're not positive, just being pushed away from each other. So the electron is what balances the negative charge of the nucleus, or specifically the proton. So protons and electrons are attracted to each other. That's what keeps the atoms together. So instead of the protons and the electrons and the neutrons just kind of falling apart, the protons and neutrons stay together because of gravity inside that nucleus. The electron and the proton are attracted to each other because they have opposite charges. And the reason that the electrons don't just smash into the nucleus and be attracted is because they're flying around. So the motion of the electrons around the nucleus keeps them from being sucked into the nucleus or attracted to the nucleus because of the opposite charges. But because there's opposite charges, that keeps the electrons from flying around away and out of the atom. So there's kind of all of these attractions happening. So the protons and the neutrons are attracted to each other because of gravity, which is a pull that keeps them together. The proton and the electron are attracted to each other because of opposite charges, but they don't stick together because the electrons are moving, they're flying around. So that's kind of what builds an atom. So if we think about all the things in space, or anything in our room, or anything under the sea, or underground, or in our refrigerator, all of it is made of atoms. And these are the particles that are in those atoms. And depending on how many protons, how many neutrons, how many electrons, how much energy these electrons have, and are they staying in one level or moving to different levels, that's how we get different things in the universe, whether it's something out in space or something sitting in front of you right now. Those are the things that we know about the atoms. All right, go ahead and take a little break and do a Costa Level 1 question so far. You get the answer right from the notes. So this could be list the 3 particles inside an atom or define a proton, those kinds of things. Okay? Let's keep going. So now the question is, well, how do we organize all those different particles? Well, a long time ago, many scientists wanted to organize the known elements. Instead of just having a whole bunch of a list with no organization, you'll learn more about that if you take chemistry in maybe a couple years or maybe next year, depending on what your schedule allows. But the scientists wanted to organize the elements into something called the periodic table of the elements, which I sometimes call PTOTE. PTOTE, PTOTE, periodic table of the elements. And it looks kind of like this. Now, there's lots of different versions in terms of colors and shading and things like that, but the actual elements and their numbers, this is the only order, the only organization that we have. There are 118 known or created elements, and they go in order on the table by the number of protons. So it's the protons that define the element. So the reason that this is hydrogen and nothing else is because it has 1 proton. The reason this is zirconium and nothing else is because it has 40 protons. And that is identified by the atom's number or atomic number. So the number that goes in order 1, 2, 3, 4, 5, all the way to 118, that is the atomic number. It tells us the number of protons and it identifies the element. I put a periodic table for you in Schoology. I would like you to put that into Notability so you have it all the time when you need it. Or if you have access to a printer, printing that periodic table would be really nice because then you have it when you need it for any type of assignment. So the way that we organize the elements or atoms is by the periodic table. And then other than atomic number, there's one other piece of information we'll use for now. Now, we'll learn lots more about lots of other parts of the periodic table in chemistry and maybe even a little bit in biology. But for now, when we use the periodic table, here's what I want you to know. I want you to know that the atomic number is that whole number, the one that goes in order, 37, 38, 39, 40, 41, all the way to 118. That is the atomic number. And remember, that's the number of protons in an atom, and it's what defines the element. The other number on your periodic table, and you could write this right on your periodic table. So I should have said that first. So if you had already put this periodic table, this one, into your notability, you can write this stuff right on there. So the atomic number is this whole number, and the atomic mass, which kind of like it sounds, is the mass of the different atoms. That's this number with a decimal. And see, it goes to two decimal places when it's atomic mass. We're going to sometimes round this, like 10.81 would round to 11, or 12.01 would round to 12. When we round it, that's not atomic mass anymore. That's going to be something called mass number, which we'll talk about in a little bit. But when we use our periodic table, these are the two numbers that you need to know: atomic number, which is given, and atomic mass, which is given. The atomic mass is like the mass of the atom. Like, imagine you could take the mass or the atom and put it on a balance. This would be the number that one atom would have. And then the atomic number, remember, is the number of protons. So that's some stuff we know about the periodic table. So again, we're getting a little bit into chemistry here, but that's useful for what we're going to be doing when we think about some of the particles in space. All right, go ahead and take your second brain break. Do a level 2 kind of question. A great one would be, what is the atomic mass for? And then pick any element that sounds good, because then you would have to use the periodic table to look it up and define it, and you'd have to use your notes to remind yourself what atomic mass is. So that would be a great one. All right. Level 2 question done. Let's finish up our notes. The last piece of our notes today is I want you to start thinking about what an atom would look like in terms of particle drawings. So remember the other day when we did particle drawings for the sample of metal, the water in the glass, and the helium in the balloon, we just drew kind of dots and circles to represent it. Well, now we're going to be a little bit more specific. So if I want you to draw an atom, we're going to draw something that kind of looks like this. So protons and neutrons are in the middle. That's called the nucleus. And then the electrons are flying around the outside. So what you'll do is you'll pick an element, or I'll pick it for you. You'll find the number of protons, because that's the same as the atomic number from the periodic table. And you'll put those in the center, like with a P+ for protons, which have a positive charge. Then it turns out that the atomic number also tells us the number of electrons when we're just dealing with an atom. So that word is specific. If the electrons are not equal to the protons, we won't call it an atom. We'll call it a different vocab word, which we're going to learn about next time. So for now, if we're talking about an atom, atoms are neutral. So electrons, which are negative, are the same number as the protons. And you're going to put those around the outside like this with an E negative, because electrons have a negative charge. Now we got to figure out the neutrons, and the neutrons take a little bit of work. So what you'll do is you'll find the atomic mass for whatever element we're using, and you'll round it to a whole number. That is known as the mass number. And the mass number has something to do with the neutrons. We're going to learn a little bit more about that tomorrow. For now, just know that the mass number minus the atomic number, which remember, atomic number is the same as the protons. So really, mass number minus protons equals the neutrons. And we're going to put those in the center just with an N. So the protons will show as a P+, the electrons will show as E negative flying around the outside, and the neutrons will put as an N in that nucleus with the protons. Let's go ahead and draw one together. So let's do one together. How about fluorine? So this is fluorine. This is its atomic number. This is its atomic mass. So step 1 was choose an element. Well, I did that for you. I picked fluorine. Step 2 was look at the atomic number, and those are the protons. Put them in the center, and we're going to call it P+, like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 protons, which identifies this as fluorine. So the atom's number or atomic number is the number of protons. We put those in the center. Next, we said, and we know that because this is an atom, the atom of fluorine, the protons which are positive equal the electrons which are negative. So if there's 9 protons, there will also be 9 electrons. And we're going to put those around the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then now every positive balances every negative. So now already this atom would be neutral, which is what we're trying to show. The electrons are flying around the outside. Notice that there's lots of space in between there and those nucleus. That nucleus right now just has the protons, but it's packed in the center. So there's my protons, there's my electrons. But remember, there's 3 subatomic particles. So the last particle we need to draw is the neutrons. Remember, this takes a little bit of work. First, you need to take the atomic mass and round it to the nearest whole number. So if 18.99 was a whole number, you take the right before the decimal, look at the next number for rounding. It would round up, so the mass number is 19. Then I told you that this thing called the mass number minus the protons, and remember that's the same as the atomic number, mass number minus atomic number, or mass number minus protons equals neutrons. So if I take the mass number of 19 minus the protons, which was 9, that will equal 10 neutrons. So now I know I need to put 10 n's in the middle of this with the protons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons. This is the atomic particle drawing for fluorine. So you're showing me how many protons there are, how many neutrons there are, how many electrons there are. You're showing me that the electrons are flying around the outside of the nucleus, and inside the nucleus are the neutrons and the protons. So now as a scientist, you're showing me really specifically what fluorine would look like. And then if I drew any other atom, it wouldn't look the same. So as a scientist, you're showing me you understand the tiny details that make up atoms, that make up everything. So that's the last part of our notes for today, thinking about drawing atom particles. So go ahead and do your last level 3 question. You could do something like, imagine a world where there was no protons. So what would what would change about the way the atom looked? Or defend why we should know about the particles in an atom. That would be a good idea too. All right, that brings us to the end of our day 2 of Unit 3. So here's what I want you to do. Finish up any Costa questions if you didn't already do so, and do today's summary, which should answer the EQ. And then I have an atomic art assignment, which is the same kinds of particle drawings we were just doing, but for 4 different atoms, just so you can practice it. And it's not due till tomorrow. So if you're watching this on Wednesday when this video was assigned, the assignment is not due till tomorrow. So you could come to Zoom tomorrow with questions, and then you could turn it in if you have any questions. All right. Thanks so much for learning more about atoms with me, and we will see you at our next Zoom session. Bye.